All right, ladies and gentlemen, these video notes are slides 13 through 18, and these are going to show you how to solve a system of equations using something we call substitution. And if we look here, it says that an algebraic method for solving systems is often superior to graphing, and especially when fractions are involved. And imagine if you have two lines on a graph, they don't always cross. Or they cross at a place that's not integers. And if they intersect at a place that's not integers, it's really hard for us to know the exact solution. So solving things algebraically is actually probably more typical. So one of the algebraic methods, the substitution method, okay, which is what we're learning here, relies on having a variable that's isolated. So what does that mean, to isolate a variable? It means to get one of the variables, either x or y. Now, a lot of times we have some other variables than x or y, but this illustrates the point. Get one of the variables by itself on one side of one of the equations, because you remember now we have two equations. Okay, so that's what substitution is kind of based on, is you're isolating a variable x or y on one side of the equation by itself. Okay, so it says, thus you start this method by choosing one of the two equations and isolating for either x or y. So on this next slide, slide 14, we're going to work through an example of this. So you don't really have to write much here. Just watch for these next couple slides. So we've got a system of equations, A and B, and we want to solve them, which means we're looking for, okay, solve means the point where the lines intersect. Okay, point where the lines intersect. So the first thing we do is we have to select an equation to solve for one of the variables. Now, there's oftentimes a better equation than the other to do this with. So if you look at the two equations up here, A and B, which one makes more sense to isolate? Well, this y right here doesn't have a coefficient. It doesn't have a number next to it. So it makes sense to isolate equation A. And when we do that, we subtract. So here's equation A right here. And we're going to subtract the 3x from each side. So now we have a new equation. We're going to call it equation C. And it is the same as A, only it has isolated the x. Okay? I mean the y, sorry. So we've done what is our first step, which is isolate the y. And notice we have a new equation, and we're going to call it C. Also, note that y is equal to this, right? Y and 5 minus 3x are the same quantity. That's important for our next slide. Okay, so step 2. So because y is equivalent to y is equivalent to 5 minus 3x. So remember from just above, you can see it in your notes. That's what we figured out. So what we have to do is put that into the other equation, the equation that we did not use to isolate. So that equation was 2x minus 3y equals 7 right here. And what we want to do is substitute, right? That's what this is called, substitution. And that's what we're going to do here. Because we need to have only one variable in an equation. We can't solve an equation that has two variables in it, right? We can't solve this equation right here because it has both an x and a y. So what we want to do is get only one variable, and this method allows us to get only one variable. So notice that what they did here was they replaced this y with the thing that y is equal to, which is 5 minus 3x. Everything else is the same. Okay? So they replaced this y right here with remember, y is equal to 5 minus 3x from the work we just did. They replaced it with the thing that y is equal to. Okay, and then I'm going to simplify it, and this is actually step 3 in the steps of how you do this, is to simplify your equation. So you have to be sure and multiply these, distribute this negative 3. Negative 3 times 5 is negative 15, and negative 3 times negative 3x is plus 9x. Be careful with that. So then I combine my like terms. I have 2x and 9x, which is 11x. And then I'm going to add 15 to both sides here. So they didn't show you this, but what they did was they add 15 to both sides. Okay, and so we come up with 11x equals 22. And then we're going to divide both sides by 11, right, to get x equals 2. Okay? So now we know that the place where these two lines intersect has an x value of 2. Okay? This is key. This is half of our answer. We now have to find the y coordinate. So at the end of this slide, I'm going to give you the steps for this. This is step 4. And step 4, we're going to substitute again. And in this case, since we know 2, we now know that x is equal to 2, right? So we're going to take any of the equations. It doesn't matter which one. In your book, when they did this, they used equation C, which was the new equation that we formed. I would suggest that instead of using an equation that you have manipulated, this will work, it's okay, but I don't recommend it, because if you manipulated the equation wrong, then your answer might work even though it's not correct. So I would go back to equation A or B and use one of them. So, I don't know, you can use either one. I'm going to use 3x plus y equals 5. Okay? So, what we just discovered was that the x was 2. Right? So, here I have 3 times whatever x is plus y equals 5. And we know that the x is 2. So now I'll simplify this and I get 6 plus y equals 5. And I subtract 6 from both sides, I get y equals negative 1. Okay, which is the same thing they got over here when they did it in equation C. Okay, so I get y equals negative 1. Now I know that I've got an ordered pair in which the x equals 2 and y equals negative 1. That's an ordered pair 2, negative 1, right? So if we sketched these graphs or graphed them, this is where they would intersect. Okay? So this is the solution. So our solution is 2, negative 1. Now, our last step that we never want to forget is checking. Right? So if indeed this is the ordered pair where these two lines intersect, then this ordered pair should be on both lines. In other words, both lines should, both equations should be true if in fact, if in fact this is a solution. So I'm going to take equation A. This was equation A from the very beginning. And I'm going to plug in my answers. So remember, my answers were 2 and negative 1. So the x is 2, the y is negative 1, and then I'm going to solve this and see if it works. So I get 6 plus negative 1 equals 5. 5 equals 5. Hooray. It works. Right? It checks in that equation. Now, it has to check in both equations. It can't just be one of them. So the other equation is 2 times x minus 3y equals 7. And the reason I'm putting the little x and y underneath these is because I want to remember what goes in there. You don't have to do that if you don't need to. So my x is 2, my y is negative 1. So now I'm going to simplify these. 2 times 2 is 4. Minus 3 times negative 1 is negative 3, but you have it, you're subtracting it, so it's plus 3 equals 7. And I get 7 equals 7. Hooray. It works. Okay? If you'd like to see some more examples, there are examples on page 158 in your book, numbers 1, 2, and 3, and they're all demonstrated. You can see what's what on those. Okay, so here I laid out the steps for you. So here's your first step. I'm not going to read all the way through this because you can, but basically the first step is to solve one of the equations for one variable, right? The second step is substitute what we got into one of the equations. And I would say here one of the original equations. Third, you're going to solve your new equation that you came up with. Fourth, you're going to take the value you got in the last step from solving equation B, and you're going to substitute it back into equation A. Okay, and last but not least, that'll give you another variable. And last but not least, we're going to check in both of the original equations. Okay, those are your 5 steps. So as you do the sample problems, example problems, which are in another video, you can follow these 5 steps. So I put a slide on here for things to remember. Anything you want to write here to take notes on the substitution method is great. Okay, so to see the 3 example problems, the video notes, that is slides 19 through 21, that has the 3 examples on it. Okay, thank you.